Welcome to Gate Concept. In this video, we will discuss some question of power system that are asked in the Gate 22 examination, 2022 examination. So in this video, we will discuss all the question that relates to the power system that was asked in the Gate 2022 examination. So let us start the session from this question. That is question number first. The question number first is the most commonly used relay for the protection of an alternator against loss of excitation is. So this is question number one. So we all know the offset Maho relay is that type of relay which is used for the protection of alternator against loss of excitation. So the right answer for this question will be option A. So I will write here this relay is used for the protection of alternator alternator against loss of excitation. So basically this is theoretical type of question. The next option is overcurrent relay. Overcurrent relay, this is again a protective relay. An overcurrent relay is a type of protective relay which operate when the load current exceeds a pickup value. So it is not used for the protection of alternator against loss of excitation. This is a type of protective relay. It is a type of protective relay. Protective relay it is a type of protective relay which operates which operates when the current exceed a pickup value. Exceed a pickup value. Next relay is the differential relay. It is used for the protection of large power transformer. Protection of large power transformer. Large power transformer against internal short circuit. Against internal short circuit. Internal short circuit. The last one is the Buckles relay. We know it is used for the protection of transformer from internal fault. So this is used for the protection of transformer. Protection of transformer from internal fault. From internal fault. So the right option for this question will be, that is option number A. Offset Maho relay is used for the protection of alternator against loss of excitation. So the next question is, So this is our next question. So this question is asking the geometric mean radius of a conductor having four equal strands with each strand of radius r as shown in the figure below is. So basically the question is asking about the GMR. GMR. We know uh, each conductor having a radius of r. So basically the distance between center to center, the distance between the center to center will be, if this is r, this is also r, so the distance will be 2r from center to center. So here also the distance would become 2r, and from this center, from this center the distance will be, so from this center the distance will be, this is 2r, 2r, this is also 2r. So this is right angle triangle. So this will give, suppose that this is A, B, C. So AC square will be equal to AB का whole square plus BC का whole square. So this will be 2R का whole square. This is BC is 2R का whole square. This will give 8R का whole square. So the length of AC becomes 2 root 2 R. So we know GMR is given, that is R dash, distance of first conductor. Let us suppose this is the first conductor. So distance between center to center will be 2r. So again let us suppose that this is our second conductor, third conductor. So distance would become 2r, and that again distance between A and C is, that is 2 root 2 r. So this is the formula for GMR. So this will give, we know r dash is 0.7788 r, 2r, 2r, 2 root 2 r to the power 1 upon 4. So after solving this, we will get the result, that is 1.723 r. So this is our right answer. So GMR will be 1.723 r. So this was our question 2. Now coming to the next question, that is question number 3. So in power system in this year 2022 examination, theoretical type of questions are asked. So this is question number 3. This is again a very simple question. The valid positive, negative and zero sequence impedance in per unit respectively for a 220 kV fully transposed 3-phase transmission line from the given choice are. So इस क्वेश्चन को हमें सॉल्व करना है ऑप्शन देखकर. तो हमारे पास जो कॉन्सेप्ट है बिहाइंड द पॉजिटिव, नेगेटिव एंड जीरो सीक्वेंस इम्पीडेंस of a fully transposed 3-phase transmission line, that positive sequence, that is x1, and the negative sequence, that is x2, are equal, and the zero sequence is greater than positive sequence as well as negative sequence. Both sequences are equal, so the negative sequence is greater than x1, or we can say x2. So from this concept we can say the option number B is the most appropriate answer. So the right answer for this question will be option number B, क्योंकि यहाँ पे पॉजिटिव और नेगेटिव को इक्वल किया गया है और जो नेगेटिव सीक्वेंस इम्पीडेंस है वो ग्रेटर है x1 या x2 से. ठीक है। और यहाँ पे अगर ए ऑप्शन की बात करें तो ये दोनों डिफरेंट है, ये गलत हो जाएगा। ठीक है, ये गलत हो गया। अगेन यहाँ पे पॉजिटिव नेगेटिव और जीरो सीक्वेंस तीनों बराबर हैं, ये भी गलत हो गया, तीनों बराबर नहीं होंगे। और यहाँ पे अगेन पॉजिटिव नेगेटिव डिफरेंट है, तो ये भी ऑप्शन नहीं होगा। सो द राइट आंसर फॉर दिस क्वेश्चन इज ऑप्शन नंबर बी। सो अगेन किसी को अगर ये पता होगा कि किसी भी थ्री फेज ट्रांसमिशन लाइन में, फुली ट्रांसपोज थ्री फेज ट्रांसमिशन लाइन में पॉजिटिव और नेगेटिव जो इम्पिडेंस होते हैं, पॉजिटिव नेगेटिव जो इम्पिडेंस होते हैं, पॉजिटिव नेगेटिव सीक्वेंस इम्पिडेंस वो इक्वल होते हैं, और जो जीरो सीक्वेंस इम्पिडेंस होता है वो ग्रेटर होता है। तो बस इतने ही कॉन्सेप्ट से क्वेश्चन बन जाता है। सो द नेक्स्ट क्वेश्चन इज क्वेश्चन नंबर 4। So this is our last question from power system, I think. So this is question number 4. इकोनॉमिक लोड डिस्पैच, इकोनॉमिक लोड डिस्पैच का ये क्वेश्चन है। द फ्यूल कॉस्ट फंक्शन इन रुपीज पर आवर फॉर 600 megawatt thermal power plant are given by plant 1 and plant 2. So the cost function in rupees per hour for two thermal power plant are given by, the equation is 350 plus 6p1 plus 0.004 p1 का whole square. C2 is 450 plus AP2 plus 0.003 p2 का whole square, where p1 and p2 are the power generated by plant 1 and 2 respectively in megawatt and A is constant. The incremental cost of power lambda is 8 rupees per hour per megawatt hour. The two thermal power plant together meets a total power demand of 550 megawatt. The optimal generation of plant 1 and plant 2 in megawatt respectively are. तो यहाँ पे हम लोग सबसे पहले इंक्रीमेंटल कॉस्ट निकालेंगे। इंक्रीमेंटल कॉस्ट तो ये क्या होता है, DC1 with respect to P1, that is 0 plus 6 plus 0.008 P1. Incremental cost for the plant first. In the same way, we can write the incremental cost for the second plant, DC2 divided by DP2, that is 0 plus A plus 0.006 P2. So the incremental cost is given lambda, that is 8 rupees per megawatt hour. So 6 plus 0.008 P1 must be equal to A plus 0.006 P2, and this is given is 8. So after solving this equation, we will get, that is 6 plus 0.008 P1 equal to 8. This will give P1 as 6, sorry, 8 minus 6, that is 2000 divided by 8. So this will give 250 megawatt. So this is P1, and from this equation we will get no, again the information is given, the two thermal power plant together meet a total power demand of 550 megawatt. So P1 and P2 must be equal to 550. So we have P1 is, P1 is 250. So the P2 will become, so P2 will become 300 megawatt. P2 will become 300 megawatt, and P1 is 250 megawatt. So the right answer for this question will be P1 equal to 250 and P2 equal to 300. So the right option for this question is B, that is 250 and 300. Okay, thank you.